Hello, and welcome to 5 Minute Math. Today we are looking at the 8th grade concept of representing linear proportional relationships. This is standard 8.5a in the great state of Texas, and we are using item number 34 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so looks like it's pretty straightforward here. We've got a table or a graph. A and B are graphs, C and D are tables. We simply need to describe a proportional relationship by the function y equals negative 2x. All right, so let's see if we can learn a little bit about this. When we have a proportional relationship, this should let us know that it's going to be in this y equals kx, right? That direct variation. The reason we know that is because proportional relationships, they go through the origin. So they don't have a plus b. There's no y-intercept. So it's just going to be y equals kx, which is what we have right here, right? So this negative 2 is going to be our constant of proportionality. Now, looking at that negative 2, it actually tells us two things. First, we've got a negative symbol, which means it is a downward slope. So when you have a negative number in that K or that M position, depending on which one you're using, it is going to be down moving from left to right, which means we can already go ahead and get rid of A simply because that's moving up from left to right. All right, so A moves up and we want something that moves down. B possibly could be it. The negative at least tells us that B is a possibility. We also know that our constant of proportionality, right, K is going to equal that y over x. In case you're wondering, we get that from our reference materials here. Right, we get our y equals kx, and if we wanted to solve for k, you would just divide both sides by y. That's that constant of proportionality. That's what this is right here, this negative 2. Which means this k equals negative 2 over 1. So now we have our slope, right? What we can look to see is, does our y move down 2? So let's check it out on B. 1, 2. So down 2, over to the right 1. Over to the right 1. Well, that does look like it could possibly work. So B is definitely in play. How can we check C and D? Well, we've got a few different options. One option, even without using the calculator, right, would be to just use this equation here and just look to see if I take my x, okay, my x value is 2. This is the equation I need to use. I'm just going to plug in my 2. Y equals negative 2. I'm going to plug in the 2 for my x, and that makes y equal negative 4 because negative 2 times 2 is negative 4. You see how I'm already off? The 2 doesn't get me the negative 2. The 2 gets me a negative 4, which means C is not going to work. We could do that same thing for X. We could also put these in Desmos and we can make a table of values and see which one works, matches up with this equation right here, right? But let's go ahead and just do it by hand. Finish here. X is going to be 2. We already know that Y is going to be negative 4 rather than this negative 1. So that's already out, right? And like I said, we could also just put it into Desmos here, and we could just graph, and we could just say y equals negative 2x, and you see we get that same one that we got that matches right up here. We can also check the table of values if we need to. Either way here, our answer is going to be B.